an object thrown at a certain angle to the ground moves in a curved path and falls back to the ground. It's something like this. This is something that you guys see day to day actually. It's not something new, but still I just want to show this. So I'm going to throw an object from here along the horizon. Okay, so something like this. So I'll throw with a speed of 90 and at an angle of 45 degree, and we have this, right? The object will take this curved path, agree? And if this was the floor, I mean, I don't have a floor per se over there, it would have stopped exactly over there, right? So the initial and the final point of the path of the object lies on the same horizontal line. So let me explain with the help of a graph. We have the object moving along the two-dimensional space. Actually 3-dimension, but we won't take the third dimension, we'll just talk about 2-dimension. Say we throw the object from this point, it'll take a certain curved path and it will fall, say, somewhere over there. So what they're telling is there is no vertical displacement. So the final point will just be from here till here. So the displacement is just this line connecting from this point to this point. Agree? That's the displacement. So the initial and the final point of the path of the object lies on the same horizontal line. That's what they mean. Right, guys? What is the work done by the force of gravity on the object? So what is the free body diagram of the object while it's moving? Once we throw it, what happens? It purely comes under the effect of gravity. Okay, so only the gravitational force will be pulling it down, nothing else. We will ignore the frictional force by the air. So basically the drag force. So we'll just keep this in mind. What happens? It's just getting pulled down. Now, if it's getting pulled down and the initial and the final position are along the same horizon, what can we tell? The displacement is along the horizontal. The displacement is along the horizontal while the force is along the vertical. Is it not? So what is the angle made between them? The force of gravity and the displacement makes an angle of 90 degree. Agree? And so what can we conclude? We can conclude that yes, there is no work done by the force of gravity in this particular case. No work is done by gravity. The reason being there is no displacement along the vertical direction. Very simple, straightforward answer. Of course, if you want to talk about angle and all of that and all of this detail, it's left to you guys. Not an issue, but yes, this is your answer. Okay, so you can pause and you can have a look and copy it to a certain extent.